The following step-by-step procedure we have to follow for approaching problems in projection of solids. One is first we have to carefully read the given problem statement. That is what type of solid is given, whether it is a prism, pyramid, cylinder, cone. Then we have to see the dimensions, their base dimensions, height. Then we have to see which parameter of the object resting on which reference plane, whether it is resting on horizontal plane or vertical planes. So here the parameter means whether the base sides, base corner, or face of the object. This is called the parameters of the object. Among these features, one parameter may be resting on any one of the reference plane. Uh, this one we have to see. The next, we have to see axis conditions. To which plane the axis of the solid is perpendicular or inclined. Usually, if it is part B question, when the axis of the solid is inclined to any one of the plane, we have to draw its front view and top view. In that case, you assume that, say for example, 2 axis of solid inclined to VP and parallel to HP. There is some type of solids, maybe prism, pyramid, cone, cylinder. You assume suitably one solid. That solid object axis is inclined to VP and parallel to HP. At that time, we have to draw its front and top view. That is the question. So here, this procedure we have to follow. If the axis of the solid is inclined to one reference plane, we have to do two-step or two-stage method. In stage 2, whatever the shape we are getting in front and top view, there is an actual front and top view. If the axis of the solid is inclined to both the reference plane, that is both the horizontal plane and the vertical plane, then we have to go for three-stage method. In stage 3, whatever the shapes we are getting in front and top view, there is an actual front and top view based on the given condition. Here, now consider axis of the solid inclined to only one reference plane. That is axis of solid inclined to vertical plane and parallel to HP. For that, this procedure we have to follow. One is that stage 1. First, assume simple position. Simple position means base of the solid completely resting on any one of the plane. So as per this problem, base of the solid resting on vertical plane. How we have to assume means, actually here the given problem is axis of solid inclined to VP. In order to get true shape, I am assuming that axis of the solid is not inclined to VP. Axis of the solid is perpendicular to VP and parallel to HP. And also the base of the solid resting on VP. In such a way, I am assuming. When the base of the solid is resting on VP, in the front view, we can see the true shape of the base. Then in the top view, we can able to see the true length of the axis. Based on the type of solids, we may get different shape in the top view. If it is a prism and a cylinder, we may get rectangle shape. If it is a triangle, that is, if it is a cone or a pyramid, we may get a triangle shape. So based on the type of solid, the views may vary. Okay. The step number 1 is we are assuming axis is not inclined, axis is perpendicular to VP. Then we are drawing the front and top view. Front view first drawn, followed by top view. So in step number 1, we are getting the true shape of the object. Then in stage 2, actually these are all the procedure we have to follow. If it is a front view, first, so the true shape of the base, there is a circle, polygon, there is a maybe it may be square, pentagon, rectangle, hexagon, triangle, whatever may be it is. The object may be anything. The base shape may be anything. It may be circle or polygon. In the top view, for getting the stage 1 top view, we have to project vertically downward from the front view. The top view will appear as a rectangle in case of prism or cylinder. It shows the true length of axis. So this is stage 1. Actually, this is not our answer for our questions. That is when the axis of the solid is inclined to VP and parallel touch P. Stage 1. In stage 1, whatever the shapes you are getting in front and top, that is not the actual answers. There is a true shape of the object in front and top. For getting actual answers, we have to rotate the stage 1 shapes suitably. What we have to do means in stage 2, apply actual inclination to VP. Incline the top view from stage 1 so that the axis makes the given angle. Example, the axis of the solid is inclined to 45 degree. So the first step, stage 1 top view has to be tilted for 45-degree inclination with respect to reference line, that is the XY line. Then keep the resting condition. While tilting the first stage top view, you have to fulfill this condition also. You have to tilt the object up to 45-degree inclinations. 45-degree means axis of the solid inclined to VP, 45-degree. That is the conditions. At the same time, keep the resting condition. That is example, one edge or base touching VP while rotating. Okay. This rotated top view becomes the actual top view based on the given conditions. In the second stage, the rotated top view, that is the actual top view for the given problem. Then to get the actual front view, what we have to do means from the actual top view, stage 2, we have to draw vertical projection lines upward. Then from stage 1 front view, draw horizontal projection lines. Then mark the intersecting points. There is a vertical projection line, horizontal projection lines will be intersecting. Those points we have to mark. Then finally carefully join these points to complete the actual front view. In stage 2, whatever the shapes we have got in front view and top view, that is above XY and below XY, that is the actual view of the object based on the given problems. So this step-by-step procedure we have to follow for solving problems in projection of solids. Then key points to remember for approaching this type of problem is in step 1, since the base is resting in VP, its a true shape appears in the front view. The top view in step 1 gives the axis in its a true length. In step 2, make sure the axis is inclined to VP as per the given angle. That is, it's maybe 30 degree, 45 degree, etc. It's maybe anything. Then projection accuracy is very important to maintain the correctness of the final view. These are all the key points one has to remember for solving problems in this type of topics.